Scientific notation is a way of expressing very large or very small numbers. If we have a really big number or a really small number, they tend to have a lot of zeros at one end or the other, which makes them pretty hard to read. Scientific notation provides us a nice compact way of saying those kinds of numbers. A number in scientific notation looks like some number times 10 to a power. This number out in front, A, is between 1 and 10. Never smaller than 1, never bigger than 10. The power, N, up here, is positive if we're talking about a very large number. And negative if we're talking about a very small number. For example, in my first one here, I have 0.00725. And I want to rewrite this using scientific notation. I'm going to take these digits that I have, 725, and I'm going to make them into a number that's between 1 and 10. I can do that if I put the decimal point right there. So 7.25 times 10 to the something. I need to know what power of 10. This is 0.00725 is a very small number. So my power is going to be negative. And the question is, how many times did I have to move the decimal point over to get my number to be between 1 and 10? Well, let's see. It started over here. I went 1, 2, 3. 3 times. So 10 to the negative 3 power. That's the same number. It gives, especially if you're a scientist and you're used to looking at them, the same information. 0.00725 is the same number as 7.25 times 10 to the negative 3 power. On the other hand, 72,500,000 is a large number. Again, I want my number out in front to be between 1 and 10, and again, that means I'm going to put the decimal point right there to get 7.25 as my number part. This is a big number, so I'm going to have 10 to a positive power, and what I'm doing is counting how many times did I have to move the decimal point to get it to the end of the number. So let's count. 1, 2, 3, 4, 5, 6, 7. So that's 10 to the positive 7, since this is a large number. So there's the same number, just written in scientific notation. We can go the other way, too. If I have a number that's already in scientific notation, I would like to put it in the form of just a regular number. 5.1 times 10 to the negative 5. Well, here are my digits, 5 and 1. My power is negative, so this is going to be a small number. My decimal point will be moving to the left to make it a small number. Here's the 5 and the 1. My decimal point started here, and I'm going to move it 5 to the left because this is a small number. I'm going to have to put in zeros as placeholders as I move it over. I can't just put a decimal point over here with nothing in between. I don't know where the 5 is supposed to be. So here we go. The first time I move it, it's to the left of the 5, and now all the rest of the times I'm going to need to put a 0 as a placeholder. So there's 2, 3, 4, 5. There's the new home of the decimal point, and I'm going to write this nice. I have 4 zeros, 5, 1. That's the same number as 5.1 times 10 to the negative 5 power. My last one over here, 6.237 times 10 to the positive 5. This is positive 5 power. So this is going to be a big number. I'm moving my decimal point to the right. I'm going to have all of those same digits, 6, 2, 3, 7, and I might need extra zeros on the end. Let's see. Here's where my decimal point started, and I'm going to move it to the right since this is positive 5. I'm going to move it to the right 5 times and fill in zeros as needed. Here we go. 1, 2, 3, 4. I need a 0 there, and one more 5. So as a number, this is 6, 2, 3, 7, 0, 0, 623,700. Same number, but now not in scientific notation.